All right, I'm going to point this at the board. All right, for anybody watching, I thought we were kind of off topic, but we're not really, because I was talking about the Inspiration 4 launch and some issues about whether or not it's a good use of millions and millions of dollars to like send people into space for a ride. So, and we got a few opinions going. I'm going to start talking about the stuff on the board in like 5 minutes. We got maybe 5 minutes we can talk about this. So, Rhea, what were you about to say?
So what I was saying is, on one hand, the logical side of my brain thinks that this is like an irresponsible use of not only money, but like resources, like
Yeah. I mean, there's a bunch of fuel got burnt, and a bunch of energy got used, and the world got polluted. And
we shouldn't be wasting energy like this and whatnot. The other part of me is like, space is cool, I want to go to space, and I'm so glad that these people get to go. But, so, it's kind of like, I feel like it's something that I don't want to completely condemn it, but I feel like we need to find a way for space travel to be sustainable and like
you talked to me about that before. Yes.
So I think that that's something that's important, and that like personally I would like to try to figure out in the future, but for now I feel like it was I don't know, I'm like on the fence about it.
I know, I get it. Okay, let me get a lot of hands up. This is great. Colin, what are you thinking?
In my opinion, I fully support sort of pioneering type space stuff. Like, even though I'm not the biggest fan of Elon Musk and all his business practices, some of the rocketry technology he's working on, I think is worth all that expense. But then there are some things like the Bezos flight.
Now listen, I actually do have a bit of an opinion here. Bezos and Branson's flights were like neat, but they were just, it's not like this.
Yeah, so
it's just not the same.
I don't care.
They're not even the same at all. Bezos riding that thing and going up and coming down, it's like, oh, he took a ride.
They changed the definition of astronaut to not fit Bezos, and I think that's...
There you go.
So I support it because it is pioneering, and it's a brand new thing that we're trying, because they took a capsule from earlier tests that were supposed to dock to the ISS, and they modified it so that the nose cone flips open.
And it has a big old you stick your head up in here and you look all over the place. I love it.
It's the largest window on any
biggest window,
and it's just it's like an aquarium dome.
It is. You're a fish in the space sea.
Exactly.
I'm going to try to get around a couple more here, and then we'll do more of what we're supposed to. But actually, I just realized there's something else neat. I'll probably show you in a minute. Yes.
Have you seen Elon Musk's concept for indentured servitude on Mars?
Oh, I don't even know.
He has this thing where he thinks that people will be like, oh, I'd love to go to Mars, and once I get there, I'll do all the work for you. He's like, oh, you can just not pay in advance, and then once you get there, you have to pay.
Oh my gosh, like indentured servitude on Mars.
Good.
Oh wow. Okay, that's a whole other thing.
Okay,
Yes.
on one hand, that's unethical.
Emma, okay, one at a time. One at a time. Emma, yes.
So yeah, I do think that maybe the money and the resources is not a great idea, but I think it's also important that we make space travel available, because it's a lot of people's opinions, well, not part of it opinion, but the part that's not opinion, that we're sort of killing Earth. So I feel like at some point it'll be important that normal people can go up.
That is a lot of what Musk is saying, is like, we're going to need, some of us going to need to get out of here sometime.
It's going to have to happen.
This is how we're going to do it.
Yeah. Neil deGrasse Tyson brought up, if we go through all the trouble to terraform Mars, why don't we just do that to our inhospitable Earth?
All good points. Yes.
I think space travel is
let me hear what Jay says. Yes.
I think space travel is great. Going to space is great and stuff. I just wish there wasn't private corporations and people doing it, and I wish it was NASA doing it, because then you could get stuff like Gavin was saying, where you have indentured servitude on Mars.
I know.
Amen.
It's a good point. I'll comment there, and then we're going to get to Ambrose and maybe Jordan, and then we got to do some stuff. Let me add I grew up during the space race, Apollo. I watched 2 episodes of original series Star Trek last night. They were funny, kind of, but I watched, and so you can see that I sort of got infected with the excitement of like going where no man has gone before, the whole thing, reaching for the stars. I saw that being done as a public effort, though, you can cynically say it was like all about beating the Soviets, and I get that stuff. I understand that. But it was exciting to watch that happen. Even during the 60s, there was an awful lot of people who thought it was a waste and hated that our taxpayer money was going for the stupid rockets. There were people who felt that way even then when a lot of us were real excited. So it's always been a conflict and a tension and a sentiment. But what I've seen since is like, NASA still does good stuff. I love NASA. I mean, they still, like Mars rovers and stuff, they're still doing pretty well with that. There's Layla.
Transfer the military budget to
But,
NASA.
yeah, but they can't seem to get their act together for the life of them with like they're trying to like make a manned rocket out of some leftover space shuttle stuff, and they can't even seem to do that. And so at a time when the government is falling flat on its face due to sclerotic, bureaucratic mess, and wonderful people, but it just ain't working very well. And Musk comes along and says, this is how you get it done. And even if he shouldn't be the one doing that, at least it's like showing what it looks like to actually get a job done. That's impressing me. Yes?
So I'm kind of like, kind of like how Ria said, I think we should be putting more resources into, like, if I'm being honest, improving Earth, because we could reasonably do that. But I also realize that there's not that much money being spent on space efforts, and that without like space travel and so on, we wouldn't have stuff such as like our phones and so many of the great things that like help improve our life.
All this,
I'm just against like stuff like space colonization essentially. I don't see any for
any what?
I don't see a need for colonization.
Oh.
Yeah. I see a need for planning, but I don't see a need.
Yeah, and it's a stage kind of thing. And by the way, Elon Musk also has this big Starlink thing going up there, which is free internet for the world. All these little satellites that get in the way of astronomers' pictures of stuff, the little things going over, he is launching massive amounts of satellites up there. What again? No, it's called Starlink.
Isn't that what
And I've never used Starlink, but Starlink is free internet for the world. Whoever wants it, basically. It's my understanding. I don't know a lot about it. And one more, and then we've got to do other stuff. Jordan.
I think there's no argument that could say that
Hey, let me hear Jordan.
It doesn't make sense to say that launching anyone into space is a waste of resources. It's new opinions, it's new data. You're not going to learn something about space by sending in robots. You're taking out the human factor. Like the only way to account for how humans will respond and act in space, send humans into space. And I think even all of those opinions, regardless of who they are valuable.
I'll tell you what, that is the perfect segue to something I'm spontaneously going to show you. It's about 5 minutes, and then I'll try to talk about what I'm supposed to be talking about. Hopefully I can make this work in 1 second. What I'm about to show you is what I'm talking about.
I love that. I watched it like 18 minutes.
Okay.
Yeah, Bill Wars. That's my man, Billy. Bill Wars.
Oh, yeah.
I wanted to go from that, and when you said that, I was like,
Got it. Everybody be quiet. I'm going to point the thing at the board so we can see this. I got to bring it up.
I've been indoctrinated.
This, everybody, shh. This is something I ran across on Astronomy Picture of the Day a while back. It is a short film, about 5 minutes long. And of course, you got to have the obligatory ad, don't we?
I don't know, do we?
Frisbee craft.
All right.
With YouTube Premium, you can not.
All right. Shh. This needs the lights down. It needs me to point this at, it needs me to point that. I think it is the same, I think I showed it to some students last year.
Is this when they go in the desert?
No, look. This is, somebody did this CGI like computer, I mean, it's very good, computer generated visions of the future. It is narrated by Carl Sagan. Carl Sagan, yeah, he's gone now. But Carl Sagan was a major popularizer. He's the one that did the original Cosmos series. And Neil deGrasse Tyson did a redux of that. But anyway, this is about an aspect of what it means to be human. And I will describe these worlds you're going to see here. And I'll also give you the little teaser that we're going to be learning about if I can ever get going with stuff. I mean, I know we get sidetracked a lot like we just did, in a good way, but you know. But the things you'll see here are things we learn about in this course. I promise we'll get to them. I'll even tell you what they are as we look. Yes? You can move. Yes, it's glare, and you get over here where you can see. Hey, in fact, I'll even, let me get a little bit of glare off the way. Does that help? All right, everybody quiet, because it's got good music in it too. Like, and listen to his words. Listen to the words. Shh.
Yeah.
Where's the sound go?
It's paused.
Oh, sorry.
The sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood.
I'll go back and tell you what some of these things that you see are meant to be.
We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species might be owed to a restless few, drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, I am tormented with an everlasting itch for things remote. I love to sail forbidden seas.
Look at this.
I want to do that.
Maybe it's a little early. Maybe the time is not quite yet. But those are the worlds, promising untold opportunities, beckon. Silently, they orbit the sun, waiting.
Okay, I'm going to tell you what a couple of these things are. You like it?
Yes.
Yeah, that was
Yeah.
Okay, let me tell you what a couple of things are. First of all, I hope you picked up the philosophical aspect of that. Talking about all throughout human history, there have been people, not all of us, some of us are content to stay home, that's fine, but something in humanity has driven us to move on and seek new pastures, so to speak, an itch, like he's talking about. And that wanderlust, I guess is the word for it, that like desire to reach out and see new things has caused us to spread across the planet and do the things we've done. And the extrapolation is that could also spread us through the solar system and maybe beyond. And the things that brings will remain to be seen. But some glimpse of that, and I'll tell you what, let me show you what these things are just real quickly. As a teaser. I'll pop to different things and show you what they were talking about. First of all, that's just the planets all in a row. Some of y'all saw that the other night. All in a row, the ecliptic. Yep, the zodiac. Now,
I was on the Earth. No, I was on the Wanderers.
Okay, this is some idea of a big spaceship, and the idea of it spinning like that, that's a classic thing. We haven't implemented that yet in any mission. But it's the idea of like you get something spinning, you make, quote, artificial gravity. Actually, it's just like centripetal force pushing you inward to make you go in a circle instead of a straight line. But it's a way to not have bone atrophy and stuff like that, and keep in shape for like being able to stand on something. Yes, Gavin?
When are we going to build a Dyson sphere?
Oh gosh, it's going to be a while. That's where you surround your entire star with a shell that absorbs the energy, and you give vast amounts of energy beyond anything you could have imagined. Let me pop to different things. Next thing, I got to get stuff done here. So there was this spaceship. Oh, that's like opening up a big thing, and what's outside? Jupiter. They're going to Jupiter. Okay, and then what's next? This is Enceladus. This is one of Saturn's moons. It's one of Saturn's moons. It is about 300 or 400 miles in diameter. It has got an ice crust underneath its ocean. And these are geysers of water. Young liquid water like in your bottle, shooting into space at high speed out cracks. This is happening. It's a real place. There's a little more of that. Oh, this is in Saturn's rings. This is what Saturn's rings are. Saturn's rings are a bunch of orbiting boulders and rocks and stuff, and one day somebody might be able to be one of Saturn's ring particles and hang out with the snowballs in space.
I want to do that.
This is really weird. Okay, this is a space elevator. This is an idea where you actually have something that it turns with the planet. It extends out so far, it has a counterweight on the end, and it's kind of like as the planet turns, it's slinging this thing around, and it's Jack and the Beanstalk. It's in tension. It's actually in tension because the centrifugal effect, so to speak, counterbalances the gravity. It is a space elevator. You don't even need a rocket. You just get an elevator and go and go and go and go and go and go, and you go into space on an elevator. Yeah.
Work by just connecting out each elevator. So I imagine like if you had one elevator.
I want to hear him.
Like one elevator going through like one planet.
Oh no, this is on a per planet basis. But you talk about like access to space. Yeah, I see. I'm not sure you can do that, but you talk about access to space. Building a space elevator means it'd be super cheap, and anybody could go to space because you just get on the elevator. You don't even have to have a billionaire get you your ticket for you. You can come back down too. So anyway, it's a space elevator. Where's it at? Everybody listen. It's a space elevator. Okay. Yeah. What's that?
Last time I tried to build a big tower to space, we all started speaking different.
I know, Tower of Babel. Yep, you good point.
Space languages.
Okay, so here we go. This is a space elevator. What the heck planet? It's Mars. Mars, you can actually have a blimp and get around in a blimp. We got a drone flying called Ingenuity. It's done like 13 flights now on Mars. It actually flies in the incredibly thin Martian atmosphere. They actually got the dang thing off the ground. It works. They fly drones on Mars now. Okay, continuing.
How come blimps would work, but I actually see why how come blimps work?
That's a whole nother physics thing. I'll leave that for now. Look at sunset on Mars. When the sun sets on Mars, it's blue. All day long, the sky is pink. And at sunset, it turns blue. And I can tell you why. And it has to do with a blue moon, and I'll tell you that some other time. Okay, this is weird. This is Saturn's moon. I love the part of this thing where an everlasting itch for things remote. I love to sail forbidden seas. I love that's Herman Melville, I guess there. Anyway, so what this is, I recognize the place. They don't say what it is, but I know what it is because I've seen the pictures. This is Saturn's moon, Iapetus.
Why is there a yin-yang symbol on Iapetus?
Whoa.
Where?
Over.
No, it's not there right now, but the idea is somebody's going to put one there. I don't know what the creator of this is dreaming up, but they think that somebody's going to put a yin-yang symbol on Iapetus.
All right, I'll do that.
You like that? Okay, so anyway, Iapetus is a weird place. It's got one side is pitch black, and the other side is snow white.
Oh, so that makes sense.
It looks like a sphere that you stuck together out of two pieces. It has a rim of mountains all the way around like the equator. Looks like it's glued together.
I think that's why they
Anyway,
put the yin-yang symbol.
this is looking at Saturn off in the distance. Let me tell you what else. Look at that, look at that, look at that. See that? Okay, continuing. This is crazy. I figured out what this is. This is a comet.
Asteroid mining.
Yeah, it's not just mining, but living in it. This is a comet, and somebody has got like a nuclear reactor down inside it. That's their source of energy, and they live in a cylinder world inside an asteroid or a comet.
Whoa.
And you get a glimpse of this if you watch the movie Interstellar. Late in the movie, there's this place where some people are living, playing baseball and doing regular stuff in the sunshine out near Saturn. It's inside a cylinder that's rotating so that there's gravity. But you could drive to your neighbor's house up there.
Can you jump?
If you get in the middle of the thing, there's some funny Coriolis effect things. But anyway, so continuing, look at that. You do a space elevator thing down into the core of it. This is people walking around on the ice sheets of Europa. Europa is a moon of Jupiter that has a 6-mile thick crust of solid ice covering a 60-mile deep ocean planet wide. We don't know what's down in there. There's like a horror movie of like creatures from down in there. Yeah.
When we saw Jupiter and the 4 moons.
Yep. This was one of them. You saw this place. You saw that place.
Which one? There was 2 on each
I
side.
don't know which was which. Europa is the second one out, so it couldn't have been the far away one.
Okay.
It couldn't have been the far away. Couple more. This is the craziest place of all. This is one of my favorite worlds. If I had to pick a neat place in the solar system, it's this. It's Saturn's moon Titan. I'm just curious. This is a poll. I'm just asking. I don't care if the answer is yes or no. I'm just curious. How many of you have heard of, already knew about Titan?
Didn't we take a picture for a Soviet?
Half of you. Okay, Titan. We have landed a spacecraft on it back in 2005. Was it landed in 2005 or 5? Yeah, 2005. We landed a spacecraft there in 2005, took exactly one picture. It's shrouded in clouds and smog. It rains there. But it doesn't rain water.
Acid.
No, it's not even acid. It's liquid. No, not diamonds. That's another place. There's a place that rains diamonds, but that's not it. No, it rains liquid methane. It rains liquid methane. The methane falls on the hills and mountains that are made of water ice. And rivers of liquid methane flow, waterfalls, rivers, flow into seas of liquid methane. And the raindrops fall slowly in the low gravity and thick air. Low gravity and thick air means you could fly. These are people. flying. Because on Titan, you can fly. What you do is you put on some wings, you work out a little, you kind of learn, you take lessons or something, and then you can start flapping. You weigh 1/7 of what you weigh on the Earth, and the air's nice and thick. You can get airborne. People could put on wings and fly on Titan. Yes?
So this might just be a misunderstanding.
It's cold. It's real cold.
This might be a misunderstanding
Yeah.
of chemistry, but if it's if it's methane, how do we land a rocket on it without having at least some sort of issue with all the methane?
And nothing's going to blow up because there's no oxygen.
Oh, that's right.
Okay. So this is Titan. No, I'm sorry. Here's the people flying on Titan. This is Uranus's moon Miranda. You can jump off a cliff that tall and land safely.
Flip.
I still want to do that.
This is back to Titan. Look at this. Look at the rings. Look at the rings in the sky. A little bit wrong with the picture because really it wouldn't be. The angle's wrong. And look at the tear of joy in this woman's eye.
There's no water on it.
Did you see that? Okay. Listen, we just spent a good bit of time doing what I didn't plan to do. That happens sometimes. Yes, Rhea.
So, quick thing I wanted to say, I would really, really like to live in space, and I also think that it would be cool if we didn't have the same societal constructs that we have on Earth in space, and we just had That's not what I meant.
Well, you want to start from scratch? That's the idea, right?
I mean, if we had the opportunity to start from scratch, I feel like maybe we could make something better.
You know, that's what happens every time people move into a new place.
But
and
yeah, I know it's not
the
gonna
degree of
happen,
success
but it's
varies.
super idealistic.
But hey, you know what? There's a place for idealism, and there's a place for dreaming.
Yeah.
And there's a place for getting down to work and dealing with the day-to-day stuff.
Right.
And I like it that there's at least a chance to look to the stars.
Right.
Okay, listen. That's enough of that right now. I'm going to talk about some of this stuff.
Neon jets.
Okay. I didn't. I'm sorry. I didn't. Hey, listen. Everybody quiet. I want to use the last 14 minutes of class efficiently. All right? Because that was a good discussion. I like that. Did you like that?
Yeah.
Okay, good. All right, so anyway, here is, for the benefit of someone who was asking questions the other day after class. Shh, everybody, full attention, please. Everybody look, got to say a lot in a few minutes. This is a timeline here. Plato, Aristotle way back here, Ptolemy here, all this keeping the torch stuff in between. Then we have Copernicus, and Copernicus barely precedes Tycho, Galileo, and Kepler, who their lives all overlap. So that's kind of a time span of this. What we were talking about, what we were getting to, and there's some stuff to really learn here, to think about. It's like, actually got to listen closely. We got Kepler starting to try to figure out what's going on. I told you Kepler's I'm going to erase this now. I told you, I won't erase that. Okay. I told you Kepler's starting assumptions. Listen to the difference. Listen to the difference. He said the sun is in the center and motionless. Okay, because it's always heliocentric. I knew that. But listen to this. He said all motions, all patterns, orbits repeat exactly with a fixed period. That is really backing off. That is a less stringent, less narrow assumption than saying they're perfect circles and the motion's uniform. It's still an assumption. It's still an assumption. So the question then is, what the heck shape are the planet's orbits? Well, here's what Kepler does. Here's the story. He wants to figure out Mars' orbit. The thing is, you can't figure out what Mars is doing unless you know what you're doing, because all the observations of Mars were made from Earth. So job one is to plot Earth's orbit. So how do you do that? You do it, amazingly, the same way you figure out you find your seat when you walk in the room. Triangulation. You may not realize you use triangulation, but you do. As you might, in fact, you wouldn't even need as much stuff in the room as we got. The room wouldn't need to be this junky with this many things in it for you to find your seat. It could be that, like, say Rhea wants to find her seat. She comes walking in the door. How do you get to your seat? You navigate, and you navigate by triangulating like this. Like, what if I suddenly had like a little blank out little moment and it's like, where am I?
That happens.
Yeah. Okay. Where am I? And I go like, oh, there's Jace. Okay, Jace is southwest of me. So I guess I must be north. I mean, maybe you don't think that way, but anyway. So I go like, Jace is southwest of me. I must be northwest of Jace. And I have a little middle map of the room in which Jace is here. And I go like, oh, I see Jace off in the southwest, so I must be northeast of Jace. Oh, whoa, I see Gavin. North. Hey, Gavin. I see Gavin northwest of me, or whatever that is.
That's the one.
That was southeast.
Southeast?
I'm sorry, anyway, don't worry about my direction labeling. Anyway, I see Gavin over here. You know what? I have just found myself. You people want to find yourself. I just found myself. I am here. I am here. And then when I move around, I go like, update position. I am here. I am here. I can plot my path. If I got, how many fixed points do I apparently need? Two. If I'm moving in a plane, if I'm moving randomly floating around the room because we live in space now, then I might need 3 points to help with the other dimension. But 2's enough if I think I'm moving in a plane. So what Kepler needs is 2 fixed points. One of them is flat out obvious. The sun. So Kepler needs observations of the sun. That's easy. It's that bright thing. So we know where the sun is in the sky. Yes?
You never gave us, I guess this will come up, but the reason why everything is like...
Oh, no, I didn't. And that's a good question. Let's hang on to that. It's coming. Okay. He needs another fixed point. He chooses, now this sounds wrong at first. He chooses Mars. There's multiple reasons he chooses Mars. One is his mind was on Mars anyway because Mars was the whole thing that was causing. It's why he got his job. That's why Kepler got a job with Tycho, because Tycho was fed up with Mars, because Mars wouldn't be where it was supposed to be. So Tycho had obsessively for like 30 years, every clear night, painstakingly observed Mars' position and wrote it down. But wait, I just said a fixed point. How in the heck is Mars a fixed point? It's not. So, wait. What assumption did I say was the second assumption? He assumed that paths repeat exactly with a fixed period. If you can figure out Mars's period, and your assumption holds, it's back in the same place. Whatever that place is, it's back in the same place every so often. Now, how do you find how often Mars is back? Who knows what it does in the meantime? Crazy stuff maybe, I don't know. But if it comes back to the same place every so often, if you can figure out how often that is, you got it made. Here's how you figure it out. Think about this part. And I actually kind of done this before. Running around the track, I have sometimes passed or been passed by other people. And I entertain myself with a little mind game of wondering nosily. Is that nosily?
Yeah.
Nosily.
That's a word.
Okay. Nosily wondering, wonder how long it takes them to run around the track. What if someone else is walking and I'm running and I'll go around the track once every 2 minutes and I find that I pass this other person who's moving in the same direction once every 6 minutes. Then I get all curious, nosy. I wonder, wonder how long it takes them. I know I take 2 minutes to go around. I know they're going the same direction as me. Like here I'm going around the track every 2 minutes, and I pass them once every 3 minutes. And then I go like, I wonder how long it takes them to walk around the track. Do you know the answer?
4.
It is 6. Now, this is one of those things kind of like saying, what's 2 squared? And you say 4, and you're adding. You're like you don't know what you're doing. You just got lucky. What's the easy way to get the number 6? 2 times 3. That doesn't work. Or if it does work, you just got really lucky. Okay, do you understand? I'm not telling you to just multiply the numbers. That generally does not work. I picked such easy numbers it happened to work. Okay. No. How do you figure out that it takes them 6 minutes? In the interest of time, I won't make you think too long. Oh, go, Aiden, go ahead and say it.
So you count, like when y'all are at the same point, you pass them.
Yep.
And then you go around and you see how many times you pass them for them to be at the same spot.
That might be one way. I do think I got something a little simpler. How about this? Look, here's the logic. I pass them every 3 minutes. That means every 3 minutes, I have just done one more lap than they did in the last 3 minutes. I know what I do in 3 minutes. I do a lap and a half. Because it takes me 2 minutes to do one. I do a lap and a half in 3 minutes. If I lap them, I must have done one more lap than they did. And if I did 1.5, they must have done 1.5 minus 1, a half. So no, they do a half a lap every 3 minutes, so they must take 6 minutes. Did y'all follow that?
No.
Yes.
Oh, I'll say it one more time. Okay, so I pass them every 3 minutes. I know that in 3 minutes, I run 1.5 laps.
Right.
I also know that I just ran one more lap than they did in the last 3 minutes because that's how I passed them, by running one more lap than they did.
I see.
So I ran one more lap than they did, and I ran a lap and a half, so they ran a half a lap in 3 minutes. Half a lap in 3 minutes is a lap in 6 minutes.
Just the difference.
Okay.
Now, I'm not going to worry with like making you do that math. I'm just saying it was doable. My question for you now is, how do you know you've just lapped Mars?
Retrograde.
It retrogrades. Yeah, tying it together. You see it opposite the sun. You see it bright. You see it going backwards. And it turns out Mars retrogrades every 600, it's 780 days. Every 780 days. Earth takes, you see Mars is the other one. You're the Earth. Earth takes basically 365 and a little bit days. And so you do the math. I'm not going to worry with telling you how to do the math. I could, but it'd take me another 10, 15 minutes. I can tell anybody who wants to know. 687 days. It takes Mars 687 days. So all you got to do, it's like this. Jace stays put, but Gavin's all hyperactive running around the room. And so how am I supposed to figure out where I am with my little I am here method if Gavin won't sit still? Well, the key is, what if I happen to know that Gavin's, or I assume that Gavin comes back to the same place every 53 seconds. Then I just need to hold my horses, be patient, and only make an observation once every 53 seconds when he's back there. So, I am here, and then it's like, where am I now? Oh God, I got to wait 53 seconds. Okay, he's back. I am here. You see, Mars isn't sitting still for us, but we assume it's back every 687 days. So all Kepler has to do is only look at Mars once every 687 days. That's almost 2 years. Boring, right?
It's forever.
That would take you like 30 years or something to plot its path.
But you could do Mercury.
Wait a minute. You're missing something here. What possibly unethical thing did Kepler do? Not kill Tycho, but steal his information.
He just looked at his stuff.
He obtained somehow his book. Here is how Kepler makes observations 687 days apart.
he uses the past observations.
Yeah, he just goes like 687 days. That would be October the whatever 1587. There, that's how he makes observations. You see the crucial role that Tycho's data plays here. Kepler is able to mine it for data. And so Kepler starts figuring out where the Earth is, and Kepler plots the orbit of the Earth. He plots the Earth's orbit. As far as he can tell, though maybe not quite, but as far as he can tell, Earth's orbit is a circle. It appears to be a perfect circle. The sun is a little off center. Is that a shocking, never before heard of idea? No. We already had eccentrics from way back, right? So it's an eccentric. Okay. Big deal. The important thing is, oh shoot. Okay, so we were a little off there on top topic. You see, we better be on topic next time. Hey, you know, keep up with the space people. They're coming back, what, tomorrow? Hope they have a safe trip home. And maybe the next billionaire will get you a ticket.
I wanted to go on the EXO mission.
Have a great weekend.
Mr. Ensberger, I wanted to go on the exhibition